Next topic in this is composition of a function. Composition of a function is nothing but product function. Okay, so here what happens, one function is from set A to set B. This F is from set A to set B. See here, three sets we have taken, set A, set B and set C. From set A to set B is taken as a F. From set B to set C, the mapping what is going, that is taken as a G. Here it is, G is a mapping from set B to set C. Then these are the two functions taken. Then composition of these two functions is denoted by G composition F. G composition F will be the mapping from set A to set C. Understood? So from first set to the last set you are taking the composition, that is taken as a G composition F. So if I am writing from set A to set B, the mapping what we have taken, I have taken three sets. Set A, set B is here. Suppose this is A and B. All the elements of set A, I have taken it as a A, and all elements of set B, I have taken it as a B. Suppose F is a mapping from A to B, I'll write it like F of A is equal to B. Correct? F of A is equal to B. If I have taken this set C and all the elements of set C, I have taken it as a C, and mapping is taken as a G. Then G of B is equal to C. This is how we write. Now composition of the function means from set A to set C I am taking. Okay. So from first set to the third set if I take, that is taken as a composition of a function, that is taken as a G composition F. And how do we define G composition F? G composition F is defined like this, G of F of X. G composition F is written like that, G of F of X. That is why we are calling that as a product function. One function is inside the other function. Okay, important concept for your competitive also, because one function will be inside the other one. In this we have differentiation also. There we are using one function inside the other one. If you understand that here, that will be easy for you to do the problems in differentiation. Okay. Next we have one theorem in this. Here also we are taking the two functions F and G. F is from X to Y and G is from Y to Z. Two functions we have taken, and the third function here will be H, and that is from Z to S. Three functions you have taken, F, G and H. These are the three functions what we are considering. So what is the statement of the theorem here? H composition, G composition F, we have to show it as H composition, G composition F. Like associative law how you write, no? So composition we can change. The brackets will be changed, but the meaning will be same. So however you take, H composition is outside, inside you have G composition F, or H composition G and outside you have composition F, both are giving you the same answer. This is the proof for that. If you have taken H composition, G composition F of X, that can be written as, see here, I told you how the composition is defined. G composition F, if I write, I can write it as G of F of X. Correct? If you are using the same definition here, then H composition is there. No, this composition will be written like this, using the bracket. See what is happening in the definition, this composition I am using the bracket. That's it. Right? So this composition I am using the bracket means that I have taken. Then what happens? H of G composition F is there. For that I am again taking the bracket. So all the composition we are going on removing. That's all. Then what I will get? H of G of X. That is equation 1. Go to RHS. RHS is like this. H composition G and then composition F. First I will see the outer composition. Okay, always see the outer composition and use a bracket and remove the composition. Then I'm using the bracket, removing the composition whatever was there. Then next time again I'm using the bracket, again I'm removing this composition. So h of g of f of x I'll get. So I am getting the same answer here. The equation 1 and equation 2 are same. Therefore I can tell that statement is correct. And this is a proof for the theorem what you have. So again see what is the statement of the theorem. H composition G composition F can be written as H composition G composition F. Understood? Okay. Let's see what is next. These 2 points you have to remember here. F and G are the two functions what we have considered, and F is a function from set A to set B. G is a function taken from set B to set C. Okay. Then if both the functions are one function, already we know now what is one function, what is onto function. Both we have learned, both we have done problems also on this. If both are one function, then composition is also one function. Composition is also one function. Can you remember this? Both are one function, then composition is also one function. Similarly, we have second one. If both the functions are onto function, both the functions are surjective function, then the composition is also surjective. Okay. So bringing it together, I can write that if F and G both are bijective, then the composition is also bijective. Clubbing this together, I can write that F is from A to B, G is from B to C, are two bijective functions, are two bijective functions. Then the composition of this function, which is taken as decomposition F, from which set to which set? From set A to set C, are bijective. Okay. The composition is bijective. So when you have taken both the bijective functions, the composition is also bijective. Okay, remember these 2 points. Let's see what is next. We have problems on this. First problem. If F is from set R to R, real to real, and G is also from real to real, two functions you have taken from real to real, then how it is taken? F of x is x square plus 1 and G of x is x minus 2. Two functions you have taken. Then find F composition G and G composition F. So how do we write F composition G? F composition G of x is written like this. F of G of x, correct? According to the definition. Now what I have to do? One function is inside the other function. So first see what is G of x and substitute that. X minus 2. G of x function is this. It is already given. So I am taking that x minus 2. Now F of x minus 2 I have to write. That means F of x is here. This one. F of x is x square plus 1. F of x minus 2 is x minus 2 whole square plus 1. In the place of x, we have x minus 2. Okay. That is equal to x square minus 2x minus 4x, minus 4x, correct, plus 4 plus 1, so plus 5. X square minus 4x plus 5 is the answer for this. And the second one, G composition F of x. G composition F of x is G of f of x. So if I am writing G of f of x, G of f of x is this x square plus 1. In the place of x, I have to write x square plus 1 in this, right? So G of x is so much. G of y will be y minus 2. G of 2 will be 2 minus 2. Like that, G of x square plus 1 will be x square plus 1 minus 2. So what is the answer? X square minus 1. Got it? So what we are doing, first we are seeing the inner function, substitute whatever is there in the question, then see f of x minus 2. If you are not understanding this, let me tell you this way. F of x is x square plus 1. F of y is y square plus 1. Right? F of 1 is 1 square plus 1. Now I have to write f of x minus 2. So f of x minus 2 will be x minus 2 whole square plus 1. So whatever is here should come in this place. That is the whole idea. So whatever I have here, I have to put here. So whatever I have here, I should bring that here. Understood? Now f of g of x and f composition g and g composition f, both we have done. Second one is here, you go through that. By the time I'll erase this part. Did you read the question? F is from R to R again, G is from R to R, then it is taken, f of x is taken as a 3x minus 2 and g of x is cos x. Okay, f of x is 3x minus 2 and g of x is cos x. Now what do I find? Find f composition g of x and g composition f of x. So f composition g, same thing what you have done in the last problem. F of g of x you can write. Okay, then f of g of x you have to bring this cos x. F of cos x means instead of x I have to bring cos x there. So the answer will be 3 into cos x minus 2. Okay, now second one. G composition f of x, that is g of f of x. G of f of x means here it is 3x minus 2. G of 3x minus 2. Instead of x we have 3x minus 2. So instead of x I have to take 3x minus 2. So that becomes cos of 3x minus 2. Is this clear for you? Whatever is there here, I have to bring that here. Okay. If it is 2, I'll bring cos 2. If it is 5, I'll bring cos 5. If it is y also, I'll write cos 5. So if it is g of 3x minus 2, I'll write cos of 3x minus 2. Simple. Okay. It will be asked for 1 mark. 1 composition, 1 mark. If they have asked like this 2 composition, it will be for 2 marks. So let's see the next one. Third one. Find and is not there. Find G composition F and F composition G. If F is from R to R and G is from R to R, and see how the functions are defined. F of x is cos x. Okay. And G of x is 3x square. F of x is cos x, G of x is 3x square. So what I have to do? I have to show that they are not equal. Okay. We'll find the value first, then see whether they are equal or not. G composition F. G composition F means G of F of x. F of x value they have given it as a cos x. G of cos x. Now x has to be replaced by cos x. Replace x by cos x in G of x. Okay. So wherever x is there, replace it by cos x. So that will give you 3 cos square x. Got it?